Welcome to NeuroSync. It contains three panels: LLM Conversation Panel, Understanding Graph Manipulation Panel, and Intent Task Mapping View. LLM Conversation Panel functions like a standard LLM interface, where users input prompts and receive responses after understanding graph is confirmed. Understanding Graph Manipulation Panel can inspect and directly edit the graph to correct or clarify task understanding, including both graph-level modification and node-level modification. Intent Task Mapping View presents a simplified view of the understanding graph aligned with the user's intent, including the following things. First, Intent Tree View, a hierarchical tree representing the user's structured goals. Second, Simplified Understanding Graph is a filtered version of the full graph which highlights nodes directly relevant to the current intent and merges irrelevant ones for clarity. Now, let's dive into the system together with Kelly. Consider Kelly, a journalism student developing a web-based system for monitoring public opinion. To support her project, she needs a web crawler capable of extracting article content. However, she lacks the programming expertise to implement one herself. As a result, she turns to NeuroSync for assistance. Kelly enters her request in the input field of Panel A for the web crawler. Unlike traditional LLM systems, NeuroSync visualizes its inferred understanding in Panel B and displays structured user intent in Panel C. The system decomposes the request into a sequence of subtasks such as fetch target webpage content via HTTP and save to Markdown, and organizes them as a task flow diagram. Panel C shows the same graph structure, highlighting all task nodes and presenting the overall intent tree as they are built from scratch. Kelly interacts with the understanding graph by dragging nodes to explore its structure and quickly identifies a misrepresentation of her original intent. Specifically, she notices that two things are different. Firstly, she wants to distinguish between different title levels and save them alongside the main article text. To achieve this, she adds a new node about extract the title at each level of the article in Panel B. To accommodate this addition, she renames the existing node save to Markdown as extract the title and body and save. She then creates appropriate links to integrate the new node into the existing task flow. After completing the initial modifications and finalizing the graph as shown in Panel B of Region 2, Kelly encounters a new challenge. She wants to save the location of original images. However, she is uncertain how to proceed. She enters her revised requirement into the modification input block in Panel B and clicks Modify. In response, NeuroSync automatically updates the understanding graph by adding a new nodes and generates an updated, simplified graph along with a highlighted intent tree in Panel C. To reflect the refined goal, NeuroSync merges relevant nodes in the understanding graph based on high-level intent tree components, such as find all images in web articles, selectively highlighting and retaining only the nodes directly associated with the updated intent. Finding it challenging to interpret the entire understanding graph, Kelly clicks the extension button to focus on a specific subintent, process the image in the article. In response, Panel B highlights the subset of nodes related to this intent, allowing her to concentrate more effectively on the text processing components. Once satisfied with the revised structure, Kelly clicks Confirm Graph, prompting the LLM to generate code aligned with her refined understanding as represented in the graph. The next round of interaction will be consistent with this round of interaction.